speaking on, low noise receiving antennas. And without any further ado, I will turn it over to Gary.
Okay, let me just get set up here real quick. Are you able to see my screen?
Yes, sir.
Okay. Well, thank you for inviting me. It's always interesting to visit with other clubs. One of the bad things, of course, COVID keeps us from meeting in person, but one of the upsides is that we're able to see and meet people from further away. One of the clubs I belong to is meeting later tonight, and they have a speaker from VE6 land. So it's nice to do a little cross-pollination and not to depend only on the club members. Okay, we're going to talk about low-band receive antennas, and I've subtitled it for all yards. Most people think of these antennas as being very large, and you have to own, a ranch or something to put them up, but that's not always the case. And we're going to talk about different types, and hopefully we will be able to find something that that you can put up if you're interested in operating the low bands. So we'll talk about the low bands and why you might want to operate them, some of the challenges, and how these received antennas can help you be successful on those. And hopefully we can find one that maybe you can buy or build that'll fit into your yard. And we'll start talking with the largest antennas and then work our way down to smaller ones. A little bit about me. I've been licensed about a little over 50 years. My main interests in the hobby are contesting, DXing, and designing and building equipment. I'm probably best known for my column in the NCJ, the National Contest Journal, which I've been writing for close to 35 years. If you're an ARL member, you can now download the latest issues for free. On the online version, and it's if you're into contesting, it's an excellent magazine. I went to school at the University of Wisconsin, where I majored in ham radio with a minor in electrical engineering. The club station there, W9YT, was a very big contest station back then. And several of the members from there are actually on the CQ Contest Hall of Fame. Retired from my day job, I was director of electrical engineering for a very large medical company and director of electrical engineering for one of the product lines. Then I also run a small company that got out of control. It was formed mostly for doing some moonlighting consulting. But I had a ham radio project that got out of control and got into QST, and I got into the ham business. And so I kind of still run in a part-time business and do things with low band antennas. I have a number of products there, antenna switching, keyers, and some other type of products. You can see I belong to a lot of organizations in radio. This is only a partial list. These are just the ones that I have an official position in. So you're not alone in clubs that are having trouble getting people to fill the officer's position. I've been kind of stuck with some of these. And I live about 25 miles northwest of Milwaukee. So what are the low bands? Well, most people consider the low bands 40 through 160. Some people think 30 meters is included. 30 meters has a lot of the same characteristics as 40 meters. And they're important because they're very reliable for short range and regional range communication. So there's a lot of nets there, traffic nets and just regular nets. And people have a lot of schedules there because they know that you can get reliable propagation. If you're a contester, you're certainly going to want to be on those bands because they're very critical. And if you're a DXer at night, they'll open up to long distances, especially in the low sunspot years. But it's a challenge. These are challenging bands to work, and challenge is probably the part of the appeal. If it was too easy, it wouldn't be any fun. The biggest challenge is noise. QRN is bad. Thunderstorms can wipe you out. You in New York or here in Wisconsin, we may be trying to listen to European stations on 160 or 80 meters, but totally get wiped out by thunderstorms down in Texas or a hurricane in the Caribbean or something, and just totally destroy the bands. And there's also QRM. One part of it is because of the short skip distances, we often hear every station on the band. If we're on 20 meters and there's a big pile up in the expedition or something, we may not hear all of the other stations in the United States calling them because they're outside our skip zone. But on the low band, you might hear everybody, and it gets pretty bad that way. And a bigger problem now is noise caused by some of the digital devices. Plasma TVs are a real killer. Phone chargers have been linked to it. Switching power supplies of all sorts. Even clothes dryers have been a big problem for some hams. And we're facing a real big problem coming up, and that's the wireless charging of electrical vehicles. So instead of having to plug in your electric car, you just pull into your garage and there's a big coil underneath, and it generates RF energy that gets coupled into your charging circuit. And we're talking tens of kilowatts here. And even though they're supposed to be outside of our frequencies, any spurious emissions or harmonics, when you're running that kind of power, can really be a problem. The ARL is putting a lot of effort into this because this could really be a killer for us. So how do you hear through all those things, this noise? Well, there are antennas that are designed for low noise reception, and that can be the answer. Some are large, like the Beverage, but there are some smaller ones, and they're available commercially. You can also make them. We'll be talking about a number of types. If you want specific design information, there's a number of books like the ARL antenna book, and ON4UN's low band DXing is excellent. And then of course on the internet. And those things are actually pretty simple for the most part, so that you can get a lot of bang for the buck with a homebrew antenna on these bands. So now let's talk about the noise and the characteristics and what's important. First thing, the signals on the low bands are often very loud, but the noise is louder. You might have signals that are S8, but if the noise is 15 over, you're going to have a hard time copying that signal. And the key is a signal to noise ratio. How strong is the signal with respect to the noise? And that's really the limitation to any sort of communication system, is you have to have a positive signal to noise ratio to be able to copy that signal. So we can use some antennas that can help us here, but unlike your tri-bander, which has gain, these antennas don't have any gain. In fact, they're very inefficient, and they actually have loss. They may only be they might be only 1% efficient. So it's like down 20 dB from your transmit antenna, but they do have directivity. And so if we can use these things to attenuate the noise more in certain directions and they attenuate the signal, we can gain something on the signal to noise ratio. And so that's basically how these antennas work. And one of the things is it's not how loud the signal is, but how strong it is compared to the noise. Here's some of the types we'll be talking about: the Beverage type antennas. We'll talk about loop antennas, and we'll talk about small magnetic loops. There's some other ones that are out there we won't cover. Vertical arrays, which are basically short verticals with amplifiers and phasing networks. And there's one called the Waller flag, which is a very nice antenna, but frankly, if I had that much tower space and put up a big antenna, I'd probably put a big 20-meter beam up, and we're talking 100-foot towers and huge antennas. So Waller flags are not very common. So the Beverage antenna is kind of the classic, and this is what everyone thinks of when they think about low band receive antennas. It was developed by a guy named Harold Beverage around 1920. He worked at GE, and it's pretty simple. It's a long wire with a terminating resistor at one end and a feed point on the other. And it's best if it's several wavelengths long in the frequency you want to use it. Here's a picture of a typical Beverage antenna, and it's composed of a long wire. Again, this could be several hundred feet long or even 1,000 feet long. A terminating resistor to ground at one end, and a transformer that converts the impedance of the Beverage antenna to your coax, 75 or 50 ohms. And if you were to stand by the coax end and then look towards the the terminating resistor, that's the direction that you'll be looking for signals coming from. So if you're pointing this thing northeast, then you'll be hearing signals out of Europe. And this is known as a wave antenna. It's a little bit different than most antennas that you're familiar with, the way it operates. And even though the wire is horizontal, it's really a vertically polarized antenna. That surprises a lot of people. So how does this work? Well, if we have a vertically polarized signal and it's traveling this way down in this direction, what'll happen is as it gets the part near the ground, it's going to be traveling slower because of the speed of light essentially is slower in ground than it is in free space. So the velocity factor is lower. So what happens is this wave gets tilted. So being vertical, it's tilted. It's kind of like the wave is dragging its feet. And because of this tilt, as it passes along this wire, it generates a current. And that current gets coupled to the transformer, converts to 50 or 75 ohms and back to your receiver, and you can hear it. Everything's fine. Now what happens when the signal's coming in the opposite direction? Well, the same sort of thing happens. The wave is tilted, a current is generated, but now it goes to a terminating resistor to ground, and so it's dissipated as heat, and we don't hear anything. Now what happens from the side? Well, we're talking about this wave having to affect a very long wire, and even then we're only getting maybe 1% of the efficiency, even with that long length. So the effect it's going to have on the wire going perpendicular to it, which is a fraction of an inch, is going to be negligible. So we're going to have a unidirectional antenna front looking in this direction and nulls off the back and off the side. Now let's take a look at a really special case. Let's say we just connected this terminating resistor. Well, again, the signal would be building up, and current would be generated along the wire. But then it gets to an open point, and then it has to go somewhere. We can't just have the energy disappear. So what happens? Well, it'll reflect back, go through the transfer and back to receiver. So now your antenna is bidirectional. You'll hear it in both directions. And that can be useful. Now, let's say you have one of these pointing towards Europe, and from your location in New York, you're not hearing people from off the back like me, but you'll hear Europeans. But now let's say it's morning, and you want to listen to say the VKs and ZLs in the South Pacific. If you disconnect this resistor, then you'll be able to hear the signals come in that direction. Now at that time of the day, it's probably around sunrise, so the signals in the direction of the normally pointing in, that's going to be in sunlight, and the D layer is going to be absorbed in those directions. So you're probably not going to hear anything off of that direction anyway. So it's possible to make these things bidirectional with some switching. Okay, here's a pattern of a typical beverage. I just modeled it with EasyNet. It's a 500-foot piece of wire. It's elevated 7 feet, 470 ohm termination. And this is the angle at 30 degrees. And you can see that the best direction is here. We've got a good front to back ratio, and we got a really good side to the front ratio here. And let's take a look at what this looks like on different bands. If we're using 160 meters, this has a gain of minus almost 16 dB. That's a lot of loss, but it does have a pretty good front to back. It's about 19 dB front to back. That's pretty good. And it's the 3 dB points here are pretty wide. It's about 100. It's about 100 degrees, so it's pretty broad. Now, if we use this thing on 80 meters, electrically it's longer. It's more wavelengths. It's twice as many wavelengths in length than it was 160. And now we see that the gain, or the negative gain, or the loss, is less than at the lower band. We see that the front to back ratio doesn't change too much. We also see it becomes more narrower, so we're not going to hear stuff off the side as well. Then 40 meters, we even have less loss. The front to back still pretty much in the same ballpark, but the beam width gets a lot shorter. So basically, the longer the wire is in wavelengths, the more narrow it's going to be. And the front to back isn't determined too much by that, but it's going to have an effect on the on the beam width and also the signal received. Should note that 7 feet is kind of a common, 7 to 8 feet is pretty common height, so that you stay above people and deer and stuff. I have mine around 7 or 8 feet, and I've even actually had deer take them out at that height, but for the most part, it's underneath them. Some things to think about if you're going to put up a beverage. Longer is better, but at some point it doesn't really help anymore. Usually around 1,200 feet is on 160 meters. It really doesn't help you much to go much longer than that. Even a half wavelength though beverage can still be helpful, but ideally it'd be 2 or 3 wavelengths as a good compromise. Keeping them above ground again, 7 feet. Now your terrain may not be level. Mine certainly is. It goes up and down, but mostly down towards the northeast. And so you want to basically just follow the terrain. You know, if you pick 7 feet, try to stay more or less 7 feet and follow the terrain. But you don't get too bent out of shape doing that, but just try to get more or less in there. If you had a tree or some other obstacle, you can do a jog around it and come back, and it's not going to really hurt the performance of the beverage. You do want to keep it away from metal objects, especially other vertically polarized ones. That can couple noise into your beverage. When you put these up, do the best you can. You know, don't say, well, I can't make it perfect, so I'm not going to put one up. Beverages just want to work, and they're an improvement, so they're worth putting up, even if you can't make them perfect. W9XT Jeff gave a talk at the August 2020 QSO Today conference. I don't know if any of you saw that. I don't know if it's still online or not, but he talked about things that you can do if you don't, you know, you're too short. You can zigzag it up and down and increase its electrical length. What the effects are of, you know, sloping and things like that. And it's not that bad. They don't hurt that much. Beverages just want to work. They're very, very insensitive antennas as far as being perfect. A variation of the beverage is a beverage on ground, sometimes called a bog. And it's like it sounds. You just lay the wire right on the ground. You don't want to bury it. If you bury it in the dirt or it's covered with snow or whatever, that'll hurt the performance. And if you can, actually moving it a few inches above the ground helps. I know of one guy who put one on a stone fence. He put along the stone fence just a couple of inches off the ground, and that helps quite a bit. One of the advantages of the bog is that you don't have to have as long, because of the velocity factor of the soil. It makes the wire look longer than as if it's elevated. So you know, 90 to 250 feet are pretty popular. One guy, I think it was W3LPL, was attributed saying that 220 feet is a kind of an optimal length for a bog on 160 meters. So if you don't have the space, you know, for a regular beverage, or if you can't put supports, that's another advantage of the bog, is that you don't need supports. You might try a bog. It has a different terminating resistance, 270 ohms instead of around 470. But one of the things is the bog is going to be quieter, but it's also going to be a much lower signal. You could lose another 15 to 20 dB of signal compared to an elevated beverage, and you might need a preamp if you're using a bog. Then there's the loop antennas. There's a number of them that are out there that are different types, and they've been described in the books in QST and online. We'll talk about these. Now, these are different than the wave antennas. These act like more normal antennas. And these loop antennas act most like 2 very closely spaced phase verticals, as opposed to a wave antenna that we had with the beverage. First one is the K9AY array, developed by Gary Breed, K9AY, very popular antenna, and he described it back in the late 90s in QST. And it's basically 2 diamond-shaped antennas at right angles, and it's switchable in 4 directions. And one of the nice things is that it doesn't take up very much space, about a 25 by 25 foot space and a 25 foot support will put one of these up. You can use a pole or even from a tree branch. One of the local guys, I gave a talk on low band antennas many years ago to the local club and described the K9AY array, and he wanted to put one up, but his wife said no more antennas. Well, there's some trees and brush and stuff in the back, and he suspended it from a tree branch. And 5 years later, she still hasn't noticed it. So it can be kind of a stealth type antenna. Here's what it looks like. We have this, like I said, a diamond shaped piece of wire. Now we have a terminating resistor and a transformer and the ground rod. Now remember on the Beverage, the terminating resistor pointed to the direction you hear from. Well, this is in the opposite. This works the opposite way. That the null direction will be in the direction of the terminating resistor. So we can build one of these, and it'll be unidirectional to one direction. But if we're smart, we can put some switching stuff down here, some relays, so we can move the terminating resistor and the transformer to the opposite sides. And now we can switch forward and back. If we're really clever, we put two of these loops at right angles, and then by switching, we can get all four directions. So it's a really nice way in a fairly small area to hear in all four directions and instantly switch. Here's a picture of the K9 array at my house. This is a PVC pipe around 25 feet. We're facing southeast here. You can kind of see the northeast wire right here. Kind of see the southeast wire here. Can't really see the southwest very well, and you can't see the northwest. But I said it's pretty small. I've never felt the need for a preamp, and I feed it with RG6, which is a 75 ohm coax for TV antennas. Here's the internal switching system that I use. Here's a transformer. I put another device, a gas discharge here for protection. That's not part of the original design. The relays, and I have some terminal blocks here for all the different connections, the control lines, and the different ends of the wires and the terminating resistors and all that stuff. And I just got it mounted in a plastic box. I got it one of those big box home improvement stores. Now on the side here is something I played around with. This picture is quite a few years old. I played around with the terminating resistor so I could actually change the value of the terminating resistor from the shack. And I found that helped sometimes. It would change the kind of the takeoff angle of the null off the back of the beam. So if you had some interference that was off the back, I could sometimes, by switching that, I could null that out by a good S unit or so. But it only seemed to work on the end. It didn't seem to work in helping the signals in the other direction. And I stopped using it. But it's something you can look at if you really want to play around with it. This is a schematic. If you go to my website, my personal website, W9XT.com, you can get a picture of this. And this is pretty much the same design that K9AY used. There's a couple of differences. His original design in the article used a couple of cores with a transform with a split tap off of there. And everyone's pretty much, including Gary, has come to the conclusion that using a binocular type core with separate primary and secondary is a much better job on keeping noise down. The original design did not have the gas discharge tube in there either. I've had problems in the past with the K9AY array and my beverages. If I left them out during the summer, someday I'd listen to it and it was just dead. And you'd look at it and it looked fine, but then you replace the transformer and everything worked fine. And the only thing I could think of is that some nearby lightning strike or whatever caused a big current spike and it changed the magnetic properties of the core. And by having the gas discharge tube in there, it protected the core, and I've never had any problems. And I put those in my commercial products too, and I've never had one returned because the transformer died. The other change was made was that I use separate control lines to control the two relays. You can kind of see the the chart here. If I don't have either of the relays on, I get northeast. If I turn on one, I get southeast. Turn on the other one, I get southwest. Turn on both of them, I get northwest. Gary's original design would put power on the line, and the coax rather, and he tapped off of there. If he put plus 12 volts on it, would turn on one relay. If he put minus 12 volts on it, turn on the other relay. And if he put 12 volt AC on there, would turn both of them on. I've had problems when using a bias T to put control voltages or voltages for preamps and stuff. It works if you do it well, but if you don't, you can inject a lot of noise. And I've just found it just safer not to do that, but that's kind of your own choice. There's a number of other types of loop antennas. We have the flag, the Pennant, and some other ones that are used. They've been described in QST and some other magazines and on the internet and some of the books. The flag antenna is basically just it's a rectangular in the shape of a flag. They're not real big. The one problem with both of these antennas is that the bottom's usually got to be about 8 feet off the ground. So you start getting up there, this is like 24 feet and you need a couple supports. The Pennant antenna is similar design, except that it's kind of over a triangle rather than a rectangle. Impedances are different. They're about 1,000 ohms. And they're pretty broad. And some people use these things and they're very happy with them. And they're unidirectional. Versions of the EWE or U this was developed by a Scottish guy, and I think he was a sheep herder or into sheep or something, and he kind of play on words. It's an upside down U, but the word U for the sheep description, and it looks kind of like a beverage, except that it's very short. The VE3DO is kind of similar, whereas the EWE uses the ground to complete the loop. His design uses wire that comes back a foot or so off the ground, and you can actually tie the two to the same ground rod here. And again, termination is about 1,000 ohms for these antennas. Another antenna which is popular because of its size is a small magnetic loop. Now these are typically 3 to 4 feet in diameter. I gave a talk a few weeks ago to a group in Minnesota, and one of the guys there said he made about a 9-foot one, and he thought it was a very excellent antenna. The couple of things that, because they're small, you can rotate them, which is obviously an advantage. But because they're small, they don't capture much signal, and all of them come with preamps, the commercial ones. Another problem is that they're bidirectional. If you look at it from the top, the nulls are basically looking through the loop. And so you aren't going to get any front to back on this. And a lot of guys who use these things not so much to hear a specific signal, but maybe to null out a noise source. So let's say you have a neighbor that's got some device that generates a lot of noise. You might just turn this thing and leave it there so it just nulls out the noise. Now the problem is you're trying to listen to northeast to Europe, and you have a neighbor to the southwest, and something like this may not help you too much. One of the problems with the Beverage antennas is that you can't turn them. It's pretty hard to turn a multiple 100-foot piece of wire in different directions, but it's possible to make them bidirectional. There's 2 ways that it's done. One of them uses separate 2 actual wires and some special multiple transformers and things, and you can look up on this in the books or on the internet and how to build one yourself, and there is also available commercially. There's another antenna which is designed by W9XT called the Bevflex, which is a very interesting antenna what he designed, which is bidirectional for beverages, and uses RG6 as the elements, and we'll kind of describe that. But it's switchable in forward and reverse directions. And in the bog or beverage, you can feed it at any point along the line. Like the beverage, you have to feed it at one end. With this, his system, you can feed it anywhere along the point. So if you have a very long beverage and the feedback could be hundreds of feet from the house, but it may get fairly close to the house. With the Bevflex, you can actually feed it at the point close to the house to reduce the amount of coax. Now, he came to me about 2.5 years ago. It was being produced and he wasn't too happy with the people manufacturing, weren't able to really keep up. It wasn't kind of their thing. So he asked me to take over the production of it and sales of it. And so I tested it for a while and I ended up doing that. And I sell that through my company, Unified Microsystems. That's also available from DX Engineering and Ham Radio Outlet. So if you permit me a few seconds to say a little commercial, but I think it's nothing else. It's just kind of an interesting design that you might find interesting, even if you aren't interested in one of these anyway. But we have kind of the same beverage situation where we have a long piece of wire, but in this case, we're using the shield of the coax as the antenna. So the signal travels along just like in a regular beverage. It gets tilted and a current gets generated on the outside of the coax. But instead of going to a terminator, it goes to a special terminator. It's a transformer that takes that signal that's on the outside of the coax, converts to 75 ohms, and then injects it into the coax back in. So you have the signal getting built up on the outside, but then it becomes part of a transmission line back to the shack, and the feed unit splits off the signal and sends it to the shack. And it's symmetrical, so signals coming the other way will do the same thing. They'll build up and get injected into the coax, picked off of the feed unit, and goes to the control box, which switches between the two, so you get instant switching in two directions. It's a really clever design that Jeff came up with. I wish I had thought about it. But you can also build in different things like the flags and the VE3DO and some of the other configurations. It's a very, very flexible system. And we also came out with a new version 2 called the BevFlex 4X/Q, which is essentially 2 BevFlex systems with a switch, so you can get 4 directions. And they don't have to be the same. You could make one a beverage, and you could make the other a bog, or the other one a flag, or something like that. So it's very, very flexible. So let's talk about some other considerations if you are going to put up a low band receive antenna. I want to talk about receiver protection, interaction with other antennas and other metal stuff, feeding it, preamps, and common mode currents. The first thing is you want to protect your receiver if it's got a separate antenna input. Some people don't have a separate receiver input, and they just switch externally, and then you wouldn't need any protection because you're transmitting into the transmit antenna and you're receiving off at different times. But if you have a separate receive input port, then you're going to want to have some sort of protection. You want to keep your transmit and receive antennas as far apart as possible. But that's easier said than done, because we're talking about 160 meters. The wavelength is 160 meters, and you'd like to be several wavelengths long. Well, that's a lot of space on these bands. So you do the best you can. There are protection devices available, commercial ones, some that disconnect the antenna when you transmit, and others that act as RF limiters. The BevFlex 4X box has some limiting diodes and a little fuse in there to help to protect, give some protection. The RF limiters are kind of like a surge suppressor on your AC line. It just prevents the big spikes from getting through to the receiver. And of course, like any antenna, you want to make sure it's disconnected when you're not in the shack if there's going to be any storms. You want to keep your antennas as far away as possible from other metal objects, so they can couple noise into it. Especially vertical antennas or any vertical piece of metal, poles or towers or whatever. You want to avoid putting your beverage over any radials that you have on a transmit vertical that can get coupled into your receive antenna. And you might consider detuning your transmit antennas. Some people will do that. Say you've got a vertical, your Sunfit tower or a Invertidal or a vertical on the low bands. They'll switch in a big inductor or something to lower the resonant frequency, so it's not on the same band. So that'll help reduce coupling. And then when they transmit, that inductor is switched out and it's just a regular antenna. But do the best you can. Don't let the perfect be the enemy of the good. Too many people I know just go and, well, I can't make it perfect, so I'm not going to do it. Well, these things are pretty forgiving, and they really can help you out, even if they're not perfect. And I've always been a big believer in multiple antennas, but you can't have too many at some point, I guess, because you have one antenna that just has a lot of different feed points. If you get too many of them, they start coupling with each other. And one of the things you'll find too about receive antennas in the low bands is that some night one antenna may work better than others. And usually one will be better on most nights, but every once in a while you'll find nights when one of the other antennas work better. Feeding the antenna, a lot of systems use 75 ohm RG6 coax. This is a coax used for TVs and cable TV. Because they make this stuff by the miles and miles, it's pretty inexpensive. It's low loss because it's got to be at low loss at really high frequencies, so it's going to be good at the low frequencies. And then some of them you can get that has a self-sealing, so if you have it outside and the rodent chews through the outer insulator, the tar-like substance will seal it back up and prevent water from getting in. That's good stuff to use. Now this coax comes in two flavors, either dual or quad shield. The dual shield has a metallized mylar, and then it has the regular metal mesh around that shielding. And the quad shield has a separate another set of those on top of it. The quad shield was needed because the dual shield just didn't have enough leakage specs for it had too much leakage for the cable industry to meet the FCC specs. So they've all switched the dual and to the quad shield rather. Quad shield's a little bit more expensive than dual. So if you're going to buy some of this stuff, I would buy the quad shield. It's supposedly good for about another 15 dB of isolation. If I was building one, I had some dual shield laying around, I'd probably just use that. But it's important to get the right connectors. If you try to use one type and use the other type of connector, you're going to have a real mess trying to make a good connection. And they do have some connectors that have a gasket for outdoor use. They're a little bit harder to find. If you can find those are good. And of course, like any other connector outside, you want to make sure that you waterproof it. You need a preamp. Most cases you don't. Most radios have more than enough gain on the low bands. In fact, if you listen to Rob Sherwood, who is this kind of the guru on receivers, he says most people should be turning your attenuator on or turn the RF gain back whenever you operate the low bands because there's more than enough gain. But if you have a really, really long coax, or you may be using a short bog or a loop, then you probably don't need a preamp. Now, some radios have preamps built in. I have an FTDX 5000, and it's got another switchable preamp that you can put in. It's designed for use when I'm on 6 or 10 meters, where it's very, very quiet band. But sometimes when I have my bog on there, I found that I could use a little bit of gain, and I've found that works without having to buy a preamp. But I don't use it all that often. Another thing that can be a problem is common mode noise. And if you get this, you can actually just lose any gain that you got, anything that you got with your receive antenna can be just shot by common mode noise. Common mode is currents, happens with normal transmission line is differential mode, and you have a current flowing on the inner conductor, and you have the same current, same magnitude current flowing on the inside of the shield. And that's normally what you want to have. But sometimes you can get a situation where you have signals flowing in both the inner and the shield, and usually the outside. And if that happens, it'll just inject a lot of noise into your receiver. There was a YouTube video for a number of years ago, and I can't find it anymore, so I think he took it down, where he put a spectrum analyzer on, and he was showing the common mode noise that was being picked up by his Beverage or loop or whatever it was. And then he had put some chokes and whatever. It was just amazing how it cut down the noise. So this is something you want to keep in mind. There's some things you can do. Burying the feed line on the way back to the shack helps. You can put chokes, either, you know, a bunch of beads over the coax, or wrap the coax around the core, and do that where it comes into the house or near the rig. 1-to-1 isolation transformers can help. The BevFlex switch box has a 1-to-1 transformer in it just to help reduce any common mode noise. And again, I don't like the bias T when you put the power on the coax for a preamp or for switching. If that's not done properly, you can add a bunch of noise that way too. So the conclusions, the low band antennas can really help you through the noise. You know, put when you can that'll fit in your yard or your budget or whatever. You can build them yourself. There's homebrew designs. There's commercial units available, and just put the best one you can up, and just go with it. And almost anything you put up is going to hear better than the transmit most of the time. And if you can have more than one, it's even better, because sometimes one will work better than the other on any given night, or even different signals from different distances. Just a quick look at my system. This is an aerial view from Google. I have a Beverage about 300 feet long, 250 feet long. It's a wire Beverage. It's been up for years. I have the BevFlex as a bog. This is the one I put up when I was first testing the design to see whether I want to get involved with this. And I was pretty much sold. That was when the VP6 Pitcairn Island expedition was going on, and I would not have worked them at 160 meters without them. That pretty much sold me. Although I did redesign a lot, and I did a lot for the waterproofing and manufacturability and some other things over the earlier version of the BevFlex. And I've got a BevFlex which is northeast southwest, and then I've got a K9AY array right here, and a couple of towers, 3 towers. And here's what my switching system is. This is a switch that I also make and sell. I've got one of those located here, and I've got one in the shack. And of course, the K9AY, you already saw the switching system. I designed and built this, so when I switch the directions, I'm switching both these 2 antennas here, and then also the K9AY in the same direction. So if I'm pointing northeast to Europe, then I can easily flip back and forth to between the two to compare. And if I'm calling CQ, like a 160 meter contest, I don't get many DX stations call me, but I'll get it. I can be, here in the central part of the US, I can get people calling me from any direction. And I usually listen on the K9AY because they're broader. And even though I can usually tell if somebody's calling off the back, if I was using the Beverage, they might call me. I'd never hear them. But if I hear them from a different direction, then I can just flip the direction switch around until they peak. And if I can hear them well in the K9AY array, we'll make the contact. And if not, then I'll flip to the Beverage, and usually that'll bring them out of the mud. But this is going to be changed. I'm running out of time here, unfortunately. I plan on turning this into an elevated BevFlex. I'm going to take this one down and put it east-west. The recent the expeditions to Africa kind of pointed out that at 90 degrees for me into Africa, they're kind of annuls, and I did have some problems. I didn't work them all on 160. I got them on 80, but I didn't get them all on 160 when I needed them. And hearing was a little bit tough. And I think by putting one east and west, and that'll give me the hearing ability that I need. So so that's it. Have anybody have any questions?
Typically, the receive antenna. Well, wait, I had a question formed and now it disappeared on me. receive antennas do or do not have as great a directive capability as like the Yagi beam antennas.
Well, it depends on which one you use and the size. If you have a very long beverage, it'll be pretty narrow. If you have a loop antenna or a fairly short, they're fairly wide. Like close to 90 degrees for a loop antenna, or a short beverage.
And for the long runs, whether you need to put supports in the middle, typically, what would that just be? A pole holding up the wire to help keep it?
Yeah, I like PVC pipe. I drive a piece of pipe into the ground and then I kind of slip that over it, and then I support it with that, with the wire about every 50 feet.
Mm-hmm.
But you can use poles, wooden poles. You don't want to use metal. You can use wooden poles. I've heard of people using bamboo. Trees will work. You'll want to use an insulator because you don't want to be, touching a tree, or you start getting noise and static pickup from that. But you can pound a nail with like an electric fence insulator, works real well.
Okay. I'm sure there's someone else who's got a question. Anybody? I know we've got people
Lou,
who work bands.
are most of these antennas monoband?
No, actually, I use them on all the bands. I don't use them on 40 all that often because I have a 40-meter beam, but I use them on 160 and 80 meters all the time. And I have used them on once in a while. The beverages or the K9AY hear better than the Yagis, especially like if it's snowing or something like that.
Now, here's an oddball question. I know you don't need them on like VHF or UHF, but will the same design work on VHF and UHF, just shorter?
Well, probably in theory, but at those frequencies, you can make Yagis and stuff that have real gain, and these are negative gain.
Mm-hmm.
So having a positive gain would actually be better. I mean, if you could build a Yagi for 160 meters, and a few people have, but they don't generally last very long and they're just monsters. You'll get the front, the back, and the front, the side that that you might get from like a beverage or a loop or something, but you'll also actually get a gain in the signal as well. It's just that those antennas are not practical for most people. I mean, I remember helping a guy put up an 80-meter beam, and I mean, the thing is bigger than a typical city lot. I mean, we can't do that.
True. We've in our field day operation, we've occasionally used a wire beam antenna where we put up a wire and at an appropriate distance put up another wire as a reflector. But
yeah, for years I've been kind of a 40-meter CW specialist for the various groups that I've worked at. I've used, for me, the holy grail is working the West Coast effectively, but I found that a dipole at 27 feet works really well because it covers the most of the population centers for around here, almost to the East Coast. But I also use a vertical for the West Coast and a NVIS antenna. If you look at W9XT.com, you can see those two antennas that I use. But I've also put beverages up, and that's helped a lot towards the West Coast. And it wasn't anything fancy, just and I used fiberglass poles that were designed for electric fence. Went to one of the farm stores that cater to farmers and whatnot, farming supplies, and they're about 5 feet or 4 feet, and they're pointed on the end of fiberglass, and I just stuck them in the ground and I ran the wire a couple 100 feet, and it really helped me between the vertical and the beverage. It really helped me to work the West Coast. which gets the number of QSOs up quite a bit.
And anyone else have any questions?
Hello, George, KD2FIU.
Sure, George.
Can
Go
you hear
ahead,
me?
George. Go ahead.
Yeah, go ahead, George.
Yeah, thank you. Excellent presentation.
Thank
I'm
you.
asking if you had ever experimented with end loading coils to a 75 or 80 meter dipole. And that being, whereas we could take maybe 80 feet of antenna and get both 40 and 80 meters on it, because we have a maybe 110 to 130 microhenry loading coil on each end with a tuned tail, which will give us 80 meters. It'll also give us 40 meters with an incredible amount of bandwidth. And well, it will have some gain because the antenna's length will be electrically about 125 feet. If you have approximately 80 feet tuned with the 120 approximate microhenry loading coils, not traps. So have you ever doubled that? So where you have an extended 80 meter dipole and put a loading coil at the end so that you don't have 265, 275 feet. You actually have much shorter distance, maybe 160 feet. Have you ever experimented with something like that by having just a loading coil, not a trap, at the end of 80 meter dipoles?
No, I've never done that. I've been fortunate enough here. I have enough land. I don't really need to, double up antennas. The one thing I have used is a center fed, longer wire fed with a feed line and a tuner. And one of the advantages of those is that you'll get a lot of, on the higher bands, it works very well like the dipole on 80 meters, but then as you go up the other band, you start getting lobes and some gain. And if you use that and point it in the right direction and the lobes are going the right direction, it can be very useful antenna for like field day. A few years ago, I went with a different group, and we had some of these at about 55 feet up in the trees, and we had a very good crew, but I think we took second around, probably third or fourth place in the 2A and field day with that, with just using those antennas.
Thank you very much.
Sure.
This is KD2FIU. No more. Thanks.
Oh.
Thanks, George. Does anyone else have any questions? Going once? Going twice?
Harry, I submitted a question in chat.
Ah, there's a question in the chat. Let's see what that says. Where's the chat window? I can't read. I don't see it in the chat.
I think
I
he might
know.
have sent it. He might have sent it to Gary as a direct
Oh,
message.
let me check
maybe.
here.
Yeah, Gary, check the chat. See if there's a direct
Can't see it either.
question to you.
Because as Joe Taylor has done amazing things with getting great signal noise ratio by software. Right now, this is only for special modes. You see this technology moving to CW or sideband. Well, the way he's done things is he's used special modulations, of course, for the different modes. There is something sort of a little bit different than this, but there are noise eliminator boxes that are both available commercially. I've never used one. I know some people have with good luck, and other people have not so much good luck. But essentially what that is you have your regular antenna, and then you have a reference antenna. and it picks up noise, and then you take those signals and you basically adjust it at the same level, and that adjustments are out of phase, so it cancels out the noise. But what Joe Taylor's doing is using DSP techniques, which are a little bit different. And one of the things is with his techniques is that it uses the fact the more you know about a signal, the longer you can listen to it, essentially the lower the data rate, the deeper you can go into the noise. And that's essentially what happens. If you look at something like the Q65, where you can set that up to take like a half an hour just to send, send the call signs. Because you can do averaging, and you can just really dig into to dig that signal out. And so I'm sure there's things you can do, and then there's DSP on noise reduction on radios that help in some cases. But you get to a point where the signaling rate of the CW or the voice especially it's too high to be able to use the kind of techniques that K1JT uses to dig out the signals. So I wouldn't say it's impossible, but it's a different. There's going to take some different ways of doing it. Most of those are way above my level of understanding of digital signal processing too.
Of course, some of that digital signal processing, well, all of it requires massive computing power, and that can introduce delays and potentially noise. Even though you're trying to eliminate noise, you can introduce RF locally.
Yep.
Does anyone else have any other questions for Gary?
Well, then, thank you. I've enjoyed meeting you all, and I'm going to bug out of here. I've got another meeting to go to here. That's becoming a problem lately. There's just too many meetings on Zoom and
Sure.
have tonight. So 73s, everybody. We'll catch you later.
Thank you very much,
Thank
Gary.
you.
I will be in touch with you about that moon bounce presentation, and I'll put you in touch with the guy who's going to be replacing me as vice president.
Yeah, I'm not making progress on my project nearly as fast as I like. So it's probably going to be next fall at the earliest before I'm ready on that one.
Okay, fine.
All right. Good night,
Thank
everyone.
you very much.